Integral representation of various bases. We're going to skip divisibility and we'll come back to that tomorrow. But for different bases, just to recognize when you see 375, that's the same as 3 times 10 to the what? If we say 300. 3 times 10 to the second, and then it's going to be plus 7 times 10 to the first, plus 5 times 10 to the 0. Or I just like to, below it, write 10 squared, 10 to the first, 10 to the 0, and you can see it's 3 times that, plus 7 times that, plus 5 times that. So that's base 10, and you all know why we use base 10. 5, 10 fingers and 10 toes. If we had, is it monkeys that have 4 fingers? How many? They don't have. They have 5? Do they? Oh, okay. Oh, I know who it was. Mickey Mouse has 3 fingers and a thumb. You know why? You know why? I think the Simpsons have the same thing, 3 fingers and a thumb. No, just cost effective. You don't have to draw that extra finger and animate it. So they use base what then? What would they, on their planet, Simpson would probably be base 8. And so we can convert to different bases. And the way that you do it is, and I really like this method, and so we're going to use the method that they have. And then I'm going to show you a little trick. 101, 101, 2 to base 10. Well, that's easy. You just take that 101, 101, and just below it think 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. So what is 2 to the 5th power? 32. 2 to 16 times 0 plus 8 times 1 plus 4 times 1 plus 0 plus 1. So you're looking at 45, right? Base 10. So switching to base 10 is no big deal. I don't think you have trouble with that. But switching off of base 10 to a different base might bother you a little bit. So take a look what they did, and I'm going to do 45 just because it's easy. Just make a little chart like this, and we're going to make this double. I like what they do with this. Let's go to base 2. Let's go to base 2 because we know that it's going to work. So let's go to base 2. Put 2's along here. 45. What's 45 divided by 2? Well, it's 22 with a remainder of what? 1. So this is going to be my remainder on this column here. Okay, now take 22 and divide by 2, and what do you get? 11. And, or actually, you're going to get 10 with a remainder of 1. Oh, no, you're going to get 11. 11 is right. I'm thinking ahead here. 11. Remainder is 0. That's right. And then divide this by 2, and you get 5 with a remainder of 1. And then you're going to divide 5 by 2, right? And so you're going to get 2, remainder 1. So far, so good? And then what are we going to divide 2 by 2, and you're going to get what? 1, remainder 0, right? Once you get to the 1 down here, you're done. And that is the end, or this is the beginning of your number. And this is the end of the number. So you're going to go 1, 0, 1, 1, 0, 1. And that is base 2. You can do that with any number. And I don't know why they did these crazy colors, but it looks good. Let's convert this one to base 3. And, all right, so I forgot to write this down. This starts out at base 9. So, that kind of makes you want to cry, doesn't it? Because if this is base 9, you got to turn this into base 10 and then go back and do base 3, right? So it's a 2 for 1. But wouldn't this be huge when you start? This is 9 to the first, right? Or 9 to the 0. 9 to the first times 7, 9 to the second times 3, 9 to the third times 2. Are you catching my drift here? It's going to get pretty horrible, and you do not want to do that, right? But what you could do, sort of, what you could do is you could say, let's do a little chart here just for fun. A little chart here. What is 0 base 9? What is that base 3? What is 0? Well, it's just 0, right? What is 1 base 9 in base 3? 1, 0, correct? Base 3, because this is 3 to the 0, 3 to the first. Wait a minute. I think it's going to be 1, 0, 0, isn't it? Because this is 0. This would be 0 plus 0 plus 9, which would be 1 base 9. Okay, and then what would, no, that's not right. This would be 0, 1 base 3. 2 base 9 is going to be 0, 2 base 3. And then what will 3 base 9 be? 1, 0 base 3, right? And then we keep going here. 4 base 9 is going to be 1, 1. 5 base 9 is going to be 1, 2. And 6 base 9 is going to be 2, 0. Right? And what's 7 going to be? You're probably saying, why is he torturing us? 2, 1 base 3. And then 8 base 9 is 2, 2 base 3. And then 9, I don't think I have any 9s up here, so I don't have to worry about it. All right, so all of these are base 3s group. Okay? And because they're base 3s, what you can do is say this is 6 base 9. I can replace it with 2, 0. This is 3 base 9. I can replace it with 1, 0. And all of these, when you just keep going down the line, 4, 5, 6, 7, or 6. Okay, let's go back here. So 5 is good. 2 is 0, 2. 3 is 1, 0. 7 is 2, 1. And 8 is 2, 2. Now, all of those in a row like that will give you the base 3. Because this is a subset of base 9, you can write it this way, and now it's base 3. And you don't have to do this division. What would that be? A bunch of times.